Hey guys, if you're in calculus, this is from 2.4. And if you are in pre-cal and we're learning calculus at the end of the year, this is from 3.1. And today we are learning the chain rule, okay? This is yet another type of derivative rule. And this derivative rule is specific to composite functions, okay? A composite function is a function that has an inside and an outside, and I'll be showing you some examples in a minute. The derivative rule, which I put here in words, sometimes it's easier to remember the jingle. So if I have f of g, g would be the inside function, f would be the outside. It would be a derivative of the outside, rewrite the inside, times derivative of the inside, okay? Now, some ways to spot that you have a composite function and that you need to do the chain rule are parentheses, radicals, and trig functions. These are the three main types that I want to show you today. So if you see a parentheses and the inside is more complex than just one simple variable, you have a composite function, okay? So your goal is to try and spot who the inside and the outside is. So in this case, I spot the parentheses. The inside is a 3x squared plus 2, and the outside would be the 4, okay? So something to the fourth would be the outside, and this would be the inside. Anytime I put radicals, it's because they require, radicals. Anytime I put arrows, it's because they require rewriting, okay? So radicals is one of those, okay? I can clearly see that I have an inside to this radical that is more complex than a simple x, okay? So the radical would be considered my outside, and this 3x squared plus 2 would be my inside. Now, in order to solve this, I need to be able to apply the power rule, and I'll show you how in a second. So I want to rewrite any sort of radical, whether it's as simple as a square root or something more complex, into exponential form, just like we did when we first learned the power rule. So again, in red, I have my inside, and then something to the 1/2 is my outside, okay? Now, we've been seeing we saw the main 6 trig function derivatives. Now we're going to start seeing them get more complex, and they have an inside. So before you were just seeing tangent of x, sine of x. Now we're seeing tangent of 3x. Now the inside is more than just a simple variable, okay? So that 3x would be your inside, and the tangent would be your outside, okay? And the second way you can see trig functions is a trig function to an exponent. This right here reads sine squared of x. Anytime you have a trig function to an exponent, they're going to put the exponent in between the word and the variable. If they put it on the right side, it means that that exponent belongs to the x and not to the entire trig function. So in saying that, any time that you get a trig function, that the whole trig function is being raised to an exponent, I want you to first, before you do any calculus, and this goes from now to the end of any calculus you take, to rewrite it with the parentheses and the exponent on the outside, okay? It's going to help us do the derivative, because in here we can clearly see that sine of x is on the inside, and the exponent of 2, the squared, is the outside, okay? So let's take a look at this first question. It says, find the derivative of f of x, which is 3x minus 2x squared all cubed at 1, 0, okay? So the first thing let's analyze is who is the inside and who is the outside, okay? We can clearly see the parentheses, and the inside of parentheses is our inside, okay? So step 1 is going to be to do the derivative, okay? So if it says f of x, I'm going to say that f prime of x, I'm going to first do the derivative of the outside. So I'm going to put my fingers here, right, covering the inside, and if I'm going to do the derivative of the outside, this is something cubed. Pretend if it was just x cubed, okay? You would multiply the 3 to the front and then subtract 1 from that 3, okay? So I would multiply the 3 to the front, and then I would subtract 1 from the 3, making it a 2, okay? That is step 1, derivative of the outside. Step 2 is to rewrite the inside. I'm going to plug that g of x back in. So I'm just going to rewrite this inside. And then lastly, it says times the derivative of the inside. So the inside now, what I underline in red, I just need to do the derivative of that. Derivative of 3x is just 3 minus derivative of 2x squared. I have 4x. Okay? At this point, I am done with the derivative. There are many ways I can clean this, but being that I'm going to plug a number in, I don't need to take the time to clean. I can clean it once I have the number in. It's going to be much easier. But just in case if you see like a multiple choice or an answer key in the back of the book, sometimes they like to multiply this coefficient with this binomial. The reason we can't multiply it into this one is because this one has an exponent greater than 1. So now, they want me to find this derivative at 1, 0. This is my x, and this is my y. Now, this function that I have here only has x's, so I don't need the 0. Next lesson, we're going to learn about derivatives with x's and y's, and then we'll need that second number, okay? I only need the x value, okay? So now I would say f prime, and the x value that I'm going to plug in is 1. So then I would say 3 times 1 minus 2 times 1 squared times 3 minus 4 times 1. Okay? Now with ones, this is going to be very easy, but please do remember to follow PEMDAS. Okay? So 1 squared is still 1. So I have 3 times 3 minus 2 squared times 4 times, well, let me write it, 3 minus 4. Okay. 3 minus 2 is 1. 1 squared is just 1. So this is 3 times 1 times 3 minus 4 is negative 1. So then this gives me 3 times 1 times negative 1, negative 3. Okay. So here is my answer of the derivative at 1. And this is if they just would have asked for the derivative. Oops, sorry there. All right, let's check out this next question. So it says to derive f of x, which is sine of x squared plus x. So I can see that sine is my outside. The parentheses tell me who the inside is. Okay? So if I want to derive this, I'm finding the derivative. F prime of x equals, first I'm going to do the derivative of the outside. Derivative of sine is cosine. I'm going to rewrite my inside. Whoops. And then times, now I'm going to do the derivative of that inside. So derivative of x squared is 2x plus derivative of x is 1. Now, please don't think that I'm doing all these extra parentheses because I'm a math teacher and I want to be neat. And no, they are necessary. If I did not have these parentheses there, this would read a completely incorrect answer. It would only multiply this cosine to the 2x instead of saying that it belongs to both of these, okay? So be very careful with that notation. Every parentheses that I put has a purpose, and it is very important. And if you plan on taking AP, when you go to do the free responses, you could do all the work correctly, but if you forget one little parentheses, it could denote a completely different answer. So be careful with that. All right, so I'm writing our next question here. Let me box off this answer. All right, derive. I'm going to give you this question that's a bit more complicated, okay? My pre-cal students, if you feel stumped on this, don't stress it. This is more for my calculus students. You'll see more of this next year. Okay, guys? So it says derive f of x, which is tangent of 5 minus sine of 2t. Okay? So when I initially look at this, if I have to pick one inside and one outside, my inside is this 5 minus sine of 2t. Okay? Some of you might be starting to catch it. There's another set of parentheses and technically another inside. Okay? So this question will have the chain rule happening twice. Okay? Which is why it's considered a higher level question. So let's start one thing at a time. Initially, my outside is tangent and my inside is this entire thing. So let's start off. saying derivative of the outside, derivative of tangent is secant squared. So I'm going to say secant squared. And then the rule says to rewrite the inside. So I'm going to rewrite 5 minus sine of 2t. Then the rule says to do derivative of the inside. So if I go to do the derivative of the inside, derivative of 5 is 0 minus. Now, when I go to do derivative of sine of 2t, here is where I have my second chain rule happening. So if you follow the order, it should naturally approach you, okay? Don't try and figure out the whole answer at once, okay? So derivative of sine of 2t, now I'm going to pretend like I've finished this question and just do the derivative of sine of 2t. Well, this has an outside and an inside. So I'm going to say derivative of sine is cosine. I'm going to rewrite the inside. And then I'm going to say times derivative of that inside, derivative of 2t is just 2. Okay? And there you can see the rest of the question. Now, of course, this could be cleaned a bit more. We can say that this is secant squared of 5 minus sine of 2t. And then obviously zeros cancel out. I'm going to multiply this 2 to the front so that it reads negative 2 cosine of 2t. Okay? This is one option of writing it. Another option, my personal favorite, is anytime I see a negative, so that this doesn't look like it's saying this minus this, I like to write the ones with negatives in the front. So again, this is just an option. You don't have to write it this way. I would say negative 2 cosine of 2t. And then times, whoops, secant squared of 5 minus sine of 2t. Okay? So either of these two are fine. Always be flexible. Remember that the way you write your answer may not be the way it appears in a multiple choice or in the back of the book. So have your mind ready to say, okay, maybe this was multiplied in the front or that. Okay? All right, our next 2 or 3 questions is going to have a combination of rules, which is what is most common to be seen in these types of derivative questions, okay? So I want you to kind of analyze the order that you're reading these. It'll tell you the order of which rule to take. So for example, if this says f of x is x squared times a square root, and then it wants you to find f prime of x, you see that you have 2 things being multiplied, okay? So if I have 2 things being multiplied, this should let me know, hey, I am doing product rule. Now, within those 2 things being multiplied, one of them has a radical, which means one of them is going to need chain, okay? So if I look at it as a big picture, the first thing I see is 2 things being multiplied, okay? That is the first thing happening. So product is the first rule I'm going to enact. Then within product rule, you're going to see that chain is going to take place, okay? Now, I told you at the beginning that the moment you see a radical, I want you to rewrite it. So the first thing I'm going to do is I'm going to say f of x equals x squared times 1 minus x squared to the 1/2, okay? Now I'm going to take it slow. Once you get a hang of this, feel free to go a little faster. This is going to be my f, and this is going to be my g, okay? So we said f prime of x is the first times the derivative of the second. Now when I do the derivative of this g, that is where the chain rule is going to take place, okay? Plus derivative of the first, that'll be a simple power rule, times rewrite g. Remember, your rewrites don't need any derivatives, okay? So one at a time. Rewrite f. Okay. Step 2, derivative of g. When I go to do this derivative of g, I have an inside and I have an outside. Okay, so here's where I have to do chain rule. So first I'm going to do derivative of the outside, so it's the 1/2 to the front. And then I'm going to subtract 1 from 1/2. If I subtract 1 from 1/2, I get negative 1/2. I rewrite the inside. And then times the derivative of this inside. Derivative of 1 is 0, minus derivative of x squared is 2x. Okay? I'm going to do plus. Now I'm going to do f prime. Derivative of f is just 2x. And then rewrite g. Okay? So if I'm color coding a little bit more, here's my f. All of this is my g prime. This is my f prime. And this is rewriting my g. Okay? So now, I'm going to start cleaning little by little. When I look at this overall, I see the main two things that are going to clean up first is that this 0 is going to disappear, and I'm just left with a negative 2x here, and that here I have a negative exponent. This negative exponent only belongs to the 1 minus x squared, which means it's going to send all of this down to the denominator with a 2. Okay? So, let's say that this whole thing here is going to end up going down with the 2. Everything else should go in the numerator. So this x squared and this negative 2x are going to get multiplied to stay in the numerator with this 1. So I'm going to have negative 2x cubed. The reason why it's cubed is because there's 2 here and 1 here. And then I have this 2 in the denominator. And then I also have this 1 minus x squared to the 1/2. So let me repeat how all of this got to where it was. Initially, the only thing I see that belongs in a denominator is this 2, right? It's already in a denominator. And then because this is a negative exponent, it's going to take all of this down to the denominator. So I put those 2 in the denominator, and then I multiply everything else. X squared times 1 is x squared. X squared times negative 2x is negative 2x cubed. Okay, I just finished cleaning this left side. Now here I'm going to say plus, I can't really do much with this. I have to say 2x okay. Now if I want to be able to combine these two, I'm going to need a common denominator. Okay, so I'm going to pretend like this is over 1. And this denominator I need on this side. So whatever I need is my denominator. I'm going to multiply top and bottom. Okay. By the way, guys, you're going to hear me say over and over that the hardest part of calculus isn't necessarily the calculus. We finished the calculus up here. Okay. The rule was easy. The hardest part of calculus is combining all the math that you've learned. Now you have to remember how to combine fractions and get common denominators. A lot of cleaning, this negative exponent, taking it down. Calculus brings together all of the rules and the math that you've learned all these years and puts it together, which is nice. You finally see the connection, but it's a lot to remember, okay? So now I have, I'm going to rewrite this left side. Okay, if I'm multiplying this to the top, I should end up here. 2x times 2 is going to be 4x. And then whenever you multiply two binomials that have the same exact base, you're going to add the exponents, okay? So for example, if I'm multiplying x squared and x cubed, the exponents are 2 and 3, the base of x is the same, then I would just add the 2 and the 3 to get x to the 6, okay? So since I have this same base, I'm going to write that base, and then I'm going to add the exponents, and a half make a whole. I don't need to make, I mean, I could put a 1 there if you want to see it, but you don't need to write that 1. All over 2 times 1 minus x squared to the 1/2, okay? Now that I have the common denominator, I'm going to write it together as 1. And then I'm going to start combining the numerators. I'm going to distribute this for x. Okay? So now I have negative 2x cubed plus 4x times 1 plus 4x times negative x squared. I end up with a negative 4x cubed. All over, I can write the denominator one time. 2 times 1 minus x squared, all raised to the 1/2. So at this point, all you have left is to combine like terms, and then I'm just going to give you some options for how you might see it written in a multiple choice or in the back of your textbook when you check your answers. So I have these two that are the same. I'm going to rewrite this. I'm going to combine that negative 2 and that negative 4, giving me a negative 6x cubed plus 4x over, and then that denominator that we had there. Okay, so this is definitely one option for your answers. Okay, some things that you might see the back of the book do. Again, these are just options. Is that you can factor out a 2 from here. You could even factor out a 2x. So you can say, okay, if I take out a 2x, then I'm left with negative 3x squared plus 2 over 2 times 1 minus x squared to the 1/2. Okay, these again just options. You could see the 2's canceled out, and you can see this written back as a radical. The only times they really write it back as a radical is when it's to the 1/2. If that was raised to 3 over 2, they wouldn't necessarily change it back to a radical, so don't stress it, okay? Again, just keep an open mind as to the different ways that you can see this answer be written. All right, and there are your two options, okay? Feel free to stop right here. All right, let's take a look at this next question. It says derive f of x, and I want you to think about what is the first operation you see happening here. Okay, hopefully you look at it and you see that there is division happening. There is x divided by some cube root. Yes, that cube root is more complicated, but the initial thing that you see is division, okay? So that means that initially I'm going to need quotient rule. Okay? Now, within that quotient rule, when I do low d high minus high d low, when I go to do d low is when I'm going to need the chain rule. Okay? Does that make sense? So, if I want to derive this, I'm going to say f prime of x equals, and you know what? I'm going to write out the words for you so that we could take this step by step. Low d high minus high d low. And then we'll worry about the low squared after, okay? So when I go to write low, remember we are going to rewrite this with exponential form. A cube root is the same thing as saying raised to 1/3, okay? So my low, I'm going to write it as x squared plus 4 raised to 1/3. I'm not doing the derivative, I'm just rewriting the denominator as a fractional exponent. Now d high, derivative of high. What is the derivative of x? Well, that one's nice and easy. It's just 1. Minus high, now I'm just going to write the top, times d low. Now when I go to do the derivative of low is when I'm going to need chain rule. Remember we rewrote low as being the inside raised to the 1/3, okay? So chain rule says derivative of the outside, so it'd be me multiplying the 1/3. Rewrite the inside. Okay. Now from that 1/3 I have to subtract 1. Okay. 1/3 minus 1 is the same thing as saying 1/3 minus 3/3. And we'll clean that after, okay? And then now times derivative of the inside. Well, I get 2x to the first plus derivative of 4 is just 0, so I don't need that, okay? Now all of this is going to be over low squared. I'm going to write it like that for now just so I don't forget it. I'm going to try and clean that so I don't waste time going crazy here, okay? So this left side cleans up really nice because anything times 1 is itself. So I'm going to have x squared plus 4 raised to the 1/3 minus, okay? Now 1/3 minus 3/3. So 1 minus 3 gives me a negative 2/3, okay? So right now the only thing I have in a denominator is this, 3. I'm going to write everything else. Actually, you know what? I'm just going to combine a few things for now just so we can take it slow. If once you feel like you're getting good at this, feel free to go much faster. X times 2x times 1/3 will give us 2x squared over 3, and then we'll clean this part next. And let's start writing our low squared here. Okay, so now I have my low, which is this, oops, and then we have to square this, okay? All right, next step. This negative exponent needs to go down to this denominator, okay? This negative exponent is going to take this entire thing down to that exponent with a 3. Not down to this one, okay? It takes it down to this denominator. So when you take it down, it becomes positive. And now for this denominator, I'm going to clean this part. An exponent raised to an exponent, you learned this back, I believe, in Algebra 2. You multiply them. So a 1/3 times 2 just gives me 2/3, okay? So now, here's a side note that I want you to take. There are many ways to clean this, and some of them are very lengthy. I'm going to teach you the way that I feel is the quickest and works every single time. Whenever I have a complex fraction, meaning a fraction within a fraction, that extra denominator right there, that 3 times x squared plus 4 raised to 2/3, that extra denominator is what I'm going to multiply top and bottom, okay? And I know it looks crazy right now, but it's going to clean this really quickly. So bear with me, okay? Now in the numerator, this is going to get multiplied to both terms. Okay, and then in the denominator, there's only one term. It's going to get multiplied right there. Okay, told you, bear with me. It's going to clean up really quickly, okay? Now, let's do one arrow at a time. These two being multiplied. The coefficient here is 1. It's 1 times all of this. So 1 times 3 is just 3. Then you see how I have a binomial that is identical, x squared plus 4? That means I'm going to write x squared plus 4, and I'm just going to add these exponents. So x squared plus 4, 1/3 plus 2/3 gives me 3/3, 3/3, which is 1 whole, right? The 1 plus 2 gives me 3/3, which is just 1, so I don't need to write an exponent. Minus, if I were to multiply this entire piece here and just put it literally times the 2x squared times all of that, do you see that all of this would perfectly cancel with this entire denominator? Okay, so here these two are going to cancel, and I'm really just left with that minus 2x squared. Okay, all over. My coefficients is a 1 and a 3. 1 times 3 is 3. And then here I have the same exact inside, so I'm going to rewrite it and just add the exponents. So I have x squared plus 4. Now 2/3 plus 2/3, I have a common denominator. 2 plus 2 is 4, and I have 4/3. We see that? All right, next step. We're almost there. I'm going to distribute this 3, and then I'm going to combine like terms. My denominator can stay exactly as is. Notice on the last one, we did show you an option of changing it to a radical. They only change to a radical. Not that you can't here. You can. Okay, you could say cube root of all of this to the 4th. But in the AP test and in the back of the books, they really only changed it back to a radical if it was a 1/2. Okay, so feel free to leave that exactly as is, the denominator, okay? All right, I didn't waste my time rewriting it here. I'm just going to draw a little arrow. All right, and you are done. Again, you're seeing yet another time that this first step, which had the calculus, had the quotient rule and the chain rule, okay? The chain rule happened right here. Was the easy part. It was all of this algebra and cleaning that was a little trickier, okay? All right, as we look at this next example, it says y equals this fraction all being squared, okay? So if I try and see what I spot first, hopefully you spot that there's something big being squared, okay? So now the order, the first thing you should be seeing is the composite function. The inside and the outside is the first thing you see, meaning chain is the first thing that's going to happen. Okay, so I'll do derivative of the outside, rewrite the inside, times derivative of the inside. When I go to do derivative of the inside is when I have division, which is why I'll have quotient then, okay? So let's take a look at this. They want us to find y prime. So here's my inside. Derivative of the outside is to multiply the 2 to the front. And then when I subtract 1 from 2, I'm left with an exponent of 1. I'm going to rewrite the inside. And now times derivative of that inside. When I do the derivative of the inside, I have quotient rule. So I'm going to do low d high, derivative of the top, derivative of 3x is just 3, minus derivative of 1 is just 0, minus high d low, derivative of low of x squared is 2x, plus derivative of 3 is 0, so I don't need that part, all over low squared. Okay? So believe it or not, this one isn't even as complicated as the last two that we did. I'm going to start cleaning. This left side already looks pretty clean. This right side looks a little messy. So I'm going to start off by distributing and combining like terms. Okay. So here I'm going to have 3x squared plus 9. Ooh, look what I forgot to do. This would have been a big mistake here. We have to also distribute this negative. Be very careful with that. Very common mistake. So a negative times a 3x and times a 2x gives me a negative 6x squared. And then a negative times a negative 1 times a 2x gives me a positive 2x. All right, so feel free to either rewrite this every single time. I'm a fan of, as long as you don't forget, of just kind of drawing an arrow every step that I wanted to just rewrite that, and I'll multiply it in at the end. So now here, I can combine the 3x squared minus the 6x squared. So I get a negative 3x squared plus the 2x plus the 9. Okay? And then so I'm going to write it this time. It depends how clean or messy the answer key wants to leave this, but technically this is an option already. Okay? Another option you're going to see is I'm going to write the denominators together, being that they're identical. They're both x squared plus 3. I can just add the exponents. This is to the first power. This is to the second. And I can write everything else in the numerator. So if this is to the first and this is to the second, now the denominator would be to the third. Okay? So here's an option that condenses them. Again, remember, I finished the calculus way back in the first step. This is all just me cleaning. Another option would be to distribute this 2 and then FOIL and distribute all of these. Not needed. We're okay to leave it just like that. All right, let's take a look at our last 4 questions for today. Let's derive these. Let's see some trig functions. So let's spot the insides. So on this first one, the inside is the 2x. So when I go to derive, I'm going to say y prime is derivative of the outside, derivative of sine is cosine. Rewrite the inside times derivative of that inside, derivative of 2x is 2. And a very clean notation always has the coefficient, the number being multiplied, and the front. So I can say 2 cosine of 2x. Okay? I'd encourage you to take a moment and pause and try and do the next ones on your own. Okay? So for this next one, my inside is that x minus 1. So derivative of the outside, derivative of cosine is negative sine. Rewrite the inside times derivative of the inside is 1 and then minus 0. So 1 times anything is just itself. I end up with a negative sine of x minus 1. This is a scenario where chain, if you would have forgotten about it, wouldn't have messed you up. But the most common mistakes on the AP is forgetting to do chain. I can tell you right now, put a red flag on it. This is known as the highlight of the mistakes on AP test, okay? For this next one, tangent of 3x squared. 3x squared is your inside. So derivative of the outside, derivative of tangent, is secant squared. Rewrite the inside times derivative of this inside, multiply the 2 to the front, and we get 6x. And again, it is very common to move this last part over to the front. One of the main reasons is so that you don't get it confused with this part. This belongs to the secant, this part does not. This is just being multiplied, okay? And let's look at this last one. This last one, I'm going to do this in, well, I'll do this in blue. I told you anytime you see an exponent that belongs to the entire trig function, I wanted you to rewrite it, secant of x to the 4th. Now notice I put the derivative symbol right away on the rest of them. Here I'm just rewriting, so I'm putting the letter y again. I'm not putting y prime yet. Okay? So again, I saw an exponent of 4, I put on the outside, so now I read secant to the 4th. Now I can see my inside nice and clear. Okay? So y prime, now I'm going to do the derivative. Derivative of the outside, now the outside is this something to the 4th, would be to multiply the 4 to the front, subtract 1 from the 4, and that gives me 3. So that's derivative of the outside. Rewrite the inside times derivative of the inside. Derivative of secant is secant tangent. Okay? Now, you could also see this as 4 times secant cubed times secant times tangent. So being that these two have the same base, I can combine them, write the base once, and add the exponents. This is to the 3rd power, this is to the 1st power. Oh, I just noticed you can't see the end. So we have 4, I'm going to say secant, there's 3 here, and there's 1 here, so it's to the 4th, times tangent of x. And that's the cleanest way you'll see that one, okay? All right, guys, and that is it for this lesson. Have a good one.